chemistry warriors, welcome back to my channel. My name is PrachiSharma and this channel is about learning chemistry for 10th grade ICSE. Finally, we are making a video on important questions of mole concept. A lot of students were struggling with this particular topic and they were requesting this again and again. So finally this video is coming out. Now, a difference between this video and other questions that I generally discuss is that in this particular video, I will be solving the questions on the screen for you guys. And for a few questions, I will show the entire detail as to how you're supposed to represent the answers in the board examinations. So, without wasting any time, let's get started with today's session. All right, students, let's get started with today's session. Now, another important thing is that I will be using a calculator on the side just to speed up the calculations for the video and make sure the video is going a little bit faster and we are not wasting any time. So let's get started with the first question. So the first question says the equation 4NH3 plus 5 oxygen will give you 4NO plus 6 H2O. This represents the catalytic oxidation of ammonia. If 100 centimeter cube of ammonia is used, calculate the volume of oxygen required to oxidize ammonia completely. So how you should start this question in the exam also. So pay attention on that. Always make sure you write the entire equation. So first thing should be write the equation. So 4NH3 plus 5 oxygen gives you 4NO plus 6 H2O. Once you have that, write the volume ratios that you have. So volume ratios is nothing but the number that is written right before your compound. So in this case, 4 volume of ammonia is to 5 volume of oxygen. So instead of writing volume, you can directly write the ratio also. So 4 is to 5 is to 4 is to 6. Okay, so this is the ratio of the products and reactants by volume that we are using in this particular reaction. Now, if we focus on this, they have said 100 centimeter cubes of ammonia is used and they're asking you the quantity of oxygen required. So that means 100 centimeter cube, I'm writing that under ammonia, and then oxygen I do not know, so X. Now let's focus on this. So how you're supposed to write in the exam? So you can say 4 volume of ammonia requires 5 volume of oxygen, and then you can say 1 volume of ammonia requires 5 by 4 volume of oxygen, and what is given to you? 100 centimeter cubes is given. So 100 centimeter cube of ammonia requires 5 by 4 times 100 volumes of oxygen. You simply solve this. On solving this, you will get 125 centimeter cube of oxygen that is required to burn or required to oxidize 100 centimeter cubes of ammonia. So that's your answer. So that's it for this one. Let's move to the next question. 200 centimeter cubes of acetylene is formed from a certain mass of calcium carbide. Find the volume of oxygen required. So we are looking for oxygen. So first, I already have the equation written. So I'm just going to speed up from that. So 2 is to 5 is to 4 is to 2 that you have. They are saying 200 centimeter cubes of acetylene. So 200 centimeter cube of acetylene is formed from a certain mass of calcium carbide. Okay. Find the volume of oxygen required. So you are looking for this. And carbon dioxide formed. You're also looking for this. During its complex combustion. The combustion reaction can be represented as this. Okay. So you're looking for two different things now. So let's see. So is to X is to X. You can just say Y. X and Y. Now, we'll focus on one thing at a time. So first we'll work on oxygen, then we'll work on carbon dioxide. So I can easily separate this into two portions. I'm not writing the entire sentences. I'm expecting that you can write that directly in the exams also. So let's see. When we're working for oxygen, so 2 volume of acetylene is giving you 5 volume of oxygen. Sorry, not giving, utilizing. Yeah, using to give for combustion. Then that means 1 volume of acetylene is using 5 by 2 volume of oxygen, and they have given you 200 centimeter cubes. So 200 centimeter cube of acetylene will require 5 by 2 times 200 volume of oxygen. correct? So if I solve this further, so this is 500 centimeter cube of oxygen is required. Okay, now let's work on y. So this is you got x. Let's work on y. Use the exact same logic. So 2 volume of acetylene is giving you 4 volume of carbon dioxide. So 1 volume of acetylene will give you 4 by 2 volume of carbon dioxide, and 200 centimeter cubes of acetylene will give you 4 by 2 times 200 volumes of carbon dioxide. So if I solve this further, you end up getting 400 volume of carbon dioxide produced. Okay, that's it. So 400 not volume, centimeter cube of carbon dioxide produced. Let's move to the next question. What volume of oxygen is required? So yeah, okay, now you're looking for oxygen again. So let me write the ratios real quick. So 2 is to 13 is to 8 is to 10. Now let's read the question. What volume of oxygen is required? So oxygen I do not know. To burn completely 90 dm cubes, so decimeter cubes of butane. So 90 is given, 90 dm cubes, or you can say liters of butane under similar conditions of temperature and pressure. That's pretty simple. You're only looking for how much oxygen is being utilized. So again, 1 volume of butane, sorry, not 1, 2 volumes of butane, it requires 13 volume of oxygen. And when I talk about 1 volume of butane, that will require 13 by 2 volumes of oxygen. We are looking for 90 liters. So 90 decimeter cube of butane will require 13 by 2 times 90 volumes of oxygen. Okay, so if we quickly solve that further, you should end up getting 585 decimeter cubes of oxygen. Okay, now let's move ahead further. We are moving on question number 4. An organic compound with vapor density, so this is an interesting one. An organic compound with vapor density of 94 contains carbon this much, hydrogen this much, and bromine this much. Find the molecular formula. So before finding the molecular formula, you're supposed to find the empirical formula. Now how do we do that? So first thing is always make the chart. So when you make the chart, the first column is element, the second column is percentage, then the next one is atomic mass, then you have relative number of atoms, and then you have the simple ratio. Okay, now let's make the entire thing. Now let me look at the numbers. So you have carbon, hydrogen, and bromine, and the percentage given is 12.67, then 2.13, and then 85.11. Now atomic masses are not given in this one, but you generally get that in the exam. So the atomic masses for carbon should be 12, hydrogen is 1, and bromine is 80. Now relative number of atoms, so you simply divide these. So I'll just do that real quick. So in this one you'll get 1.05. For the next one you have 2.13 divided by 1, you end up with 2.13. For the next one you end up with 85.11 divided by 80, you end up with 1.06. So your simple ratios simply become 1 is to 2 is to 1. So 1 to 1. Now just write the empirical formula. So you have CHBr, C is 1, H is 2, and Br is 1. So your empirical formula is CH2Br. Okay, let's move ahead further. So this is your empirical formula, and the empirical formula weight. So empirical formula weight given to you is 94. So how do we move further from this? So you, and vapor density is also given to you. The organic compound, okay, vapor density of 94. So vapor density is given to you 94, not the molecular weight. Empirical, not the so this is your vapor density. Vapor density given to you is 94. So what we do, how do we find the molecular weight? So molecular weight equals 2 times the vapor density. So 2 times 94 is nothing but 188. So that is your molecular weight. Now what you will look for, you look for number. So n, okay, n is a number. So what is n? So you have empirical formula. So I'll just write the formula here for you so you understand what I'm talking about. So molecular formula equals empirical formula times n. So this n is what you're looking for, and the formula for n is molecular weight divided by empirical formula weight. So what is the molecular weight? Molecular weight I just got 188. Empirical formula weight. So empirical formula weight is 94. Okay. So when you divide that, you get an answer as 2. So what is your molecular formula now? So your molecular formula is empirical formula, what you got? CH2Br. So CH2Br, the whole thing multiplied by 2. So when you do that, you get C2H4Br2. And this is your molecular formula. Let's move ahead from here. The next question is, oxygen oxidizes ethane to carbon dioxide and water as shown. So then you have the equation, what volume of ethane gas at STP is required to produce 8.4 decimeters of carbon dioxide at STP? And you have H given as 1, C12 and O16. So let's get started with the equation. So C2H2 plus 5 oxygen giving me 4 CO2 plus 2 H2O. Ratio is 2 is to 5 is to 4 is to 2. Correct? Now, let's see what have they given. They said what volume of ethane gas. Okay, so we are looking for ethane gas. We do not know this. And is required to produce 8.4 decimeters of carbon dioxide. So 8.4 decimeter cube is given as your carbon dioxide. So this is it. You're looking for the gas. So this is your, let me delete this. This is your X. So we'll use the same thing. So how you'll move forward with this is, you'll say that 1 volume of carbon dioxide is produced by 2 volumes of ethane. Ethane, it's ethane, right? Yes, ethane. So 1 volume of carbon dioxide gas is produced by 2 volumes of ethane gas, correct? So that means 4 volumes of carbon dioxide gas is produced by 2 by 4. No, I just wrote the entire thing opposite. So we had 4 volumes, right? So 4 volume of carbon dioxide gas was produced by 2 volumes of ethane. So C2H2. That means 1 volume of carbon dioxide gas was produced by 2 by 4 volume of C2H2. And how much do we have? We have 8.4. So 8.4 volume of carbon dioxide was produced by 2 by 4 times 8.4 volumes of C2H2. And that's it. Let's solve it quickly. So I am getting 4.2 decimeter cubes of ethane gas that is utilized to produce carbon dioxide of 8.4 volumes. Let's move to the next question. A compound made up of 2 elements X and Y has an empirical formula X2Y. If the atomic weight of X is 10 and that of Y is 5 and the compound has a vapor density 25, find its molecular formula. So let's quickly do this. So I have X and Y. So empirical formula that they have given you. So empirical formula given to you is X2Y. And if you find the weight for that, so X is given 10 and Y is given 5. So that would be 20 plus 5, 25. Now molecular weight is 2 times vapor density. Vapor density given to you is 25. So 2 times 25, 50. And now we look for N. N is what? Molecular weight divided by empirical formula weight. So molecular weight is 50 divided by empirical formula 25. So you end up with 2. So your molecular formula will be X2Y whole N. So X2Y whole 2. So X4Y2. This is your molecular formula. Let's quickly move to the next question. LPG stands for liquefied petroleum gas. Varieties of LPG are marked including a mixture of propane 60% and butane 40%. If 10 liters of this mixture is burned, find the total volume of carbon dioxide gas added to the atmosphere. Combustion reactions can be represented as follows. So two reactions are given. Okay, let's quickly look at it. So first what we'll do is we'll find the quantity that is being utilized. Okay, because they have given that in percentages. You first find it in liters because they have given you 10 liters of this mixture. So you're looking for the quantity of, or the volume in liters. So let's look at that. So quantity of propane given to you is 60% and that of butane is 40%. So 60% of what? 60% of 10 liters because you are mixing propane and butane. And when you are mixing and you're using 10 liters of that mixture, so 60% of what? 60% of 10 liters. So propane, quantity of propane will be 60% of 10 liters. So that means 60 by 100 times 10, 6 liters. And quantity of butane is 40%. So butane is 40% of 10 liters. So 40 by 100 times 10. This will give you 4 liters. So this is your quantity. So you're getting propane and butane, both of them. Now let's see. So we have one volume of propane. We are looking for what? We have 10 liters of this mixture combined. Find the total volume of carbon dioxide gas. So you're looking for the carbon dioxide gas total. So what you'll do is you'll utilize both of them separately. So that means work on the first equation, find the amount of carbon dioxide, work on the second equation, find the carbon dioxide and add them. So let me just do that. C3H8, C3H8, C3H8 plus 5 oxygen. So plus 5 oxygen is giving you 3 CO2 plus 4 H2O. So this is your equation and you're looking for carbon dioxide quantity. So this is propane. So propane now you know is 6 liters. So this is 1:5 is to 3:4. I'm again dividing this into two parts. Now how much do we have propane? Propane is 6 liters and you're looking for carbon dioxide. So 1 volume of propane is giving you 3 volume of carbon dioxide and 6 liters of propane will give you 3 times 6 liters of carbon dioxide. So 18 liters of carbon dioxide. Very simple. Let's move to the next equation. Next equation is 2C4H10 plus 13 oxygen is giving you 8 CO2 plus 10 H2O. Let's look at the ratios real quick. So 2 is to 13 is to 8 is to 10. Okay, so that means, and this, how much did we get? We get 4 liters. So 4 liters of butane. And you're looking for carbon dioxide, that is X. Okay, let's start with that. So 2, you'll simply say 2 volume of butane gives you 8 volume of carbon dioxide. That means 1 volume of butane will give you 8 by 2. And then that means 4 liters will give you 8 by 2 times 4. So you'll get 16 liters of carbon dioxide. At the end, you just have to combine both of them. So you just add up 18 and 16. So you'll say total carbon dioxide produced equals 18 plus 16, 34 liters of carbon dioxide is produced. Okay, students, I hope it is interesting so far. My target is to go up till 15 questions, so we'll just be a little more faster in the questions going further. So let's move ahead on question number 8. So empirical formula. So as soon as you see the percentages and the empirical formula question, the first thing you should do is make the chart. So let's quickly make the chart. So the first will be element, percentage, atomic mass, relative number of atoms, and a symbol ratio. So let's make this entire chart. Okay, so element, so the first element you have is sodium. Sodium given to you is 37.6%. Then you have 23.1% silicon. Then you have oxygen, 39.3, and atomic mass given to you is 23, 28 and 16. Then just divide that real quick. So if I'm dividing the 30, so I'll just write what I'm doing. So 37.6 divided by 23, I'm getting 1.6. Then 23.1 divided by 28, I'm getting 0.8. Then 39.3 divided by 16, I'm getting 2.4. Then your simple ratio. How do I get simple ratio? So 1.6 divided by 0.8, you get 2. Then 0.8 divided by 0.8, you get 1. 2.4 divided by 0.8, you get 3. So this is your simple ratio. Now let's just write that. So sodium, so Na2, silicon is 1 and oxygen is 3. So Na2SiO3. So that's your empirical formula. Na2SiO3. Now what else do you need to find? So that calculate the empirical formula of the compound having this, this and this, and that's it. You just have to find the empirical formula. Alright, let's move to the next question. Again, the empirical formula of a compound is C2H5. It has a vapor density of 29. So first of all is the empirical formula given to you is C2H5. Vapor density given to you is 29. So molecular weight of this empirical formula would be vapor density times 2. So 29 times 2 is 58. So that's your molecular weight. Now what are we looking for after the molecular weight? You look for N. So N is molecular weight divided by empirical formula weight. So molecular weight is my 58, but I did not calculate the empirical formula weight. So empirical formula weight will be C2H5. So C2, so that should be that should be 24 plus 5. So if I add that up, I get 29. So 58 by 29, and if you divide that, you get 2. Now molecular formula will be C2H5 whole N. This is N that you have got. So C2H5 whole 2. So C4H10. That's your molecular formula. Is there anything else you need to find out? No, that's it. That's all the question is asking for. Now let's move quickly on question number 10. A compound contains 87.5% by mass of nitrogen and 12.5% by mass of hydrogen. Determine the empirical formula of the compound. Again, students, we'll start with making the chart again. So the first is element, percentage, atomic mass, relative number of atoms, and simple ratio. So let's quickly start with that. So elements I have so elements I have is nitrogen. So nitrogen given to me is 87.5. Then I have hydrogen given to me as 12.5. Atomic masses for nitrogen is 14 and hydrogen is 1. Then relative number of molecules will be 87.5 divided by 14. So that would be 6.25. Then 12.5 divided by 1, that's 12.5. Now when you calculate simple ratio, it would be 6.25 divided by 6.25, 1, and 12.5 divided by 6.25, and that will be just 2. So your empirical formula, this is pretty easy, will be N1H2. So NH2 is your empirical formula. Let's move to the next question, students. So the next question is question number 11. So this question says the volume of oxygen is required to burn. What volume of oxygen is required to burn? Completely a mixture of 22.4 decimeter cubes of CH4 and methane and 11.2 decimeters of hydrogen, and then 2 reactions are given. This is similar to the one that we did for carbon dioxide. You separated the 2 equations, solve them each of them, and then at the end add the answers. So for that we calculated carbon dioxide. For this case we'll be calculating oxygen. So let's start with the first one. So we have CH4 plus 2 oxygen giving you CO2 plus 2 H2O, and then divided 2H2 plus oxygen giving you 2H2O. So what do we start with? We write the ratios first. So 1 is to 2 is to 1 is to 2. Then 2 is to 1 is to 2. Okay. Now, what is given to us? So methane is given to us as 22.4 and you're supposed to find oxygen. Then similarly on this side, hydrogen given to you is 11.9 and they're asking for oxygen. So let's make this Y. Okay, let's solve for the first case first. So 1 volume of methane is giving you 2 volumes of oxygen. So 22.4 will give you 2 times 22.4, which will be 44.8. Then let's look at the second one. So 2 volumes of hydrogen is utilizing 1 volume of oxygen. That means 1 volume of hydrogen is utilizing 1 by 2 volume of oxygen, and they have given you 11.9. So 11.9 volume of hydrogen will utilize 1 by 2 times 11.9, which should be 5.6. 5.6 liters of oxygen. So there at the end, just combine. So total oxygen required will be 44.8 plus 5.6 liters. That would be 50.4 decimeter cubes. Okay, let's move to the next one. This is question number 12. An acid of phosphorus has the following percentage composition, and then the percentages are given. Find the empirical formula of this acid and its molecular formula, given that its relative molecular mass is 162. Okay, so first we'll work on empirical formula. This is an important question, student. This has everything and a good information is given here. Like that means bigger numbers are given trying to confuse you. So first, stick to the method. If you stick to the method, you will not make any mistakes. So let's get started with the method. What does the method tell us? Method tells us make the chart. So let's quickly make the chart. We are looking for element, percentage, molecular weight, sorry, not molecular weight, atomic mass, relative number of atoms, and we are looking for simple ratio. Okay, let's start with the first one. So the elements that are given to me. So I have hydrogen. So let me just write hydrogen. It is given to me as 2.47. Atomic mass is 1. Then I have phosphorus. So phosphorus, this is given to me as 38.27 and the mass, atomic mass given to me is 31. Then after phosphorus I have oxygen. The percentage given to me for oxygen is 59.26 and I know the atomic mass is 16. So let's quickly divide these. I'll still write the division so that the students are not the students which are like not who have not practiced this enough are able to understand what I'm dividing. So 2.47 divided by 1 gives me 2.47. 38.27 divided by 31, I'll calculate that. Then 59.26 divided by 16 will give me what? Okay, so for this one, I'm getting 1.2. For this one, I'm getting 3.7. Then simple ratio. So simple ratio, what happens in simple ratio is that amongst these three numbers, whichever is the smallest number, divide all of them by that number. That means 2.47 divided by 1.2. 1.2 divided by 1.2 giving you 1. Then 3.7 divided by 1.2. So let's quickly do that. So for the first case, I'm getting 2. Then for the last case, I'm getting 3. So 2, 1 and 3. Now if you make the empirical formula, you will have hydrogen, phosphorus, oxygen. So hydrogen is 2, phosphorus is 1 and oxygen is 3. So you are getting H2PO3. This is your empirical formula. Now let's come back on the question. So the first part of the question is done. Find the empirical formula. Then they are asking find the molecular formula, and the relative molecular mass is given as 162. So in this case, they have given you the molecular mass directly. They have not given vapor density. So molecular mass is given to me as 162. Then empirical formula mass, you'll have to calculate that. That would be H2PO3. So that means 2, then 31 plus 16 times 3. So that will give you 33, 48. So you'll end up with 81. Okay, empirical formula mass is given to you now. You're looking for N. N is molecular weight divided by empirical formula weight. So 162 divided by 81, 2. So your N is 2. Now you're looking for molecular formula. So that is empirical formula. What was my empirical formula? H2PO3. So H2PO3 whole N, H2PO3 whole twice. So H4P2O6. This is your molecular formula. Let's come back to the question. So they asked you the empirical formula, that's done. Molecular formula, that's done. So everything in the question is answered. Always make sure that after answering and solving a numerical, go back to your question and check if you have successfully answered all the parts or if there is something missing out. So let's quickly move to the next question, question number 13. Again, it's an empirical formula. I can see a compound of sodium, sulfur, oxygen. Percentages are given. Find the empirical formula. Let's quickly make the table. Element, percentage, atomic mass, relative number of atoms, and simple ratio. Alright students, let's quickly do this. So the first part that is given to us is sodium. So sodium is 29.11. So sodium is 29.11. Atomic mass is 23. Then I have sulfur. Sulfur given to me is 40.51. And this is 32. Then I have oxygen given to me as 30.38. And this is 16. So relative number of atoms will be how much? That will be, that is 29. Yeah, 29.11. So 29.11 divided by 23, 40.51 divided by 32, 30.38 divided by 16. Let's quickly use the, let me just quickly calculate that. So I'm getting 1.2, 1.2 and 1.8. And the simple ratio, of course, simple ratio is 1.2 divided by 1.2, 1.2 divided by 1.2, 1.8 divided by 1.2. So this is 1, this is 1. So 1.8 divided by 1.2, I get 1.5. Now, if you do not get the simple ratios in whole numbers, then you're supposed to convert them into whole numbers. So I'm not getting, I'm getting 1.5, which is not a whole number. So how will I do that? So to convert into whole numbers, now what will you do? You'll just multiply them by any given number that can convert it into a whole number. So you have 1.5. To convert 1.5 into a whole number, just multiply it by 2, you get a 3. Right? So just multiply it by 2. So whatever numbers are not, you're not getting in whole numbers, multiply all of them with a number that all of them can convert into a whole number. So to convert them into a whole number, I'll multiply all of them by 2. So 1 times 2 will give me 2. 1 times 2 will give me 2. 1.5 times 2 will give me 3. Now I can make the empirical formula. So I have sodium. Yeah. So sodium, sulfur and oxygen. So sodium 2, sulfur 2 and oxygen is 3. This is your empirical formula. Let's see if you have anything else to be calculated in the question. They just asked the empirical formula, so that's it. Let's move to the next question. Calculate the empirical formula of the compound. So students, let me give you this as homework. So I have solved a lot of empirical formula questions for you today. Let's see if you're able to solve it on your own. So take a screenshot of this, or you can download this from the description. This is your homework question. Make sure you let me know the answers in the comment box, and whoever gets the correct answer, I will pin that on the top for other students to know the correct answer. Let's move to the next question. This is the last question for today. A hydrocarbon of vapor density 15 has 80% carbon. Calculate the molecular formula of this hydrocarbon. Okay. So, first thing is that they have given you the percentage. So, they have given you 80% carbon and it's a hydrocarbon. That means the other compound, other element that you will have would be hydrogen. So, the vapor density is given to you. You're looking for molecular formula. So to find molecular formula, first you need the empirical formula, and you do not have empirical formula here. So first we'll calculate that. So element, percentage, atomic mass, relative number of atoms, and simple ratio. Let's start solving. So carbon given to you is 80%. That means hydrogen will be 20%. Atomic mass is 12 for carbon. Hydrogen is 1. So if I calculate that quickly, so that this should be 80 divided by 12. That means 6.6. Then 20 divided by 1 is 20. Now simple ratio would be 6.6 divided by 6.6. So I end up with 1. And this would be 20 divided by 6.6, which will be 3. So that's it. Your empirical formula that you have got is CH3. This is empirical formula. Now once you have the empirical formula, what do we find out? They have given you vapor density. So you'll find out the molecular weight. So molecular weight will be 2 times vapor density. So 2 times 15. So you are getting molecular weight as 30. Now empirical formula weight, that is CH3. So C is 12 plus 3, it's 15. Now you're looking for N. What was the formula for N? Molecular weight divided by empirical formula weight. So molecular weight divided by 15. Your answer is 2. Now we look for molecular formula. Molecular formula is empirical formula. Entire thing multiplied by N. So empirical formula you got was CH3. That's right, CH3. So CH3 whole twice C2H6 is the correct molecular formula. So all right, my dear students, this was it for today's session. We were successfully able to practice about 15 questions from Mole Concept. I will put out a second part of Mole Concept also, in which we'll practice some more questions and you can gain more confidence in these numericals. If you have any doubts and queries, you can definitely reach out to me. You already know there are 3 platforms to reach out to me on, either the comment section, the Telegram channel, or you can write me an email on psclassesicse@gmail.com. Today, you will also get another sample paper for chemistry on the Telegram channel. So if you have not part of Telegram channel, you can join it, because I do post a sample paper there, and then you can send me your answer scripts for correction. So that's it for today. We'll catch up in the next session. Thank you so much. I hope you have a wonderful day.